Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at conditional probability. So this is where you're finding the probability something happens given that something else happens. So for example, the probability that your team wins sport on the weekend might go down if your star player is out. So the star player being out is the condition that changes the probability that you will win. So let's look at an example of this. So here we have a class of 29 students, 16 play AFL, 11 basketball, 10 play neither. We're going to calculate all these probabilities. Now I'll go through what they mean in a second. But in probability, hopefully we already know that when you have a question involving two sets, so here we have a set of people who play AFL, set of people who play basketball, we use Venn diagrams and two-way tables to display the information. So it doesn't matter which you use. I'm going to use a Venn diagram here and a two-way table later in the video. So what we're going to do is draw up a Venn diagram. So it always looks like a rectangle with two circles. Now each circle represents one of the sets. So I'm going to call them A for AFL and B for basketball. Now you may be wondering to yourself, hang on a minute, there's only 29 students, but 16 plus 11 plus 10 is 37. How is that possible? Well, the only way that's possible is that we've overcounted 8. Because when we added up the numbers, we got 37, which is 8 over. Now, however many you've overcounted is how many go in the middle of your Venn diagram. It's how many are in both. The only way that these numbers are possible is if we counted 8 people in the AFL category and then again in the basketball category. So the question said we need 16 in this AFL circle. We already have 8, so we need 8 more. Similarly, we want 11 in the basketball circle. We already have 8, so we need 3 more. And the 10 who play neither go outside. So displaying that information in a Venn diagram is very useful when it comes to calculating probabilities. So let's calculate each of these probabilities. Now this symbol here is read as given. So you read this as the probability of A given B. In this case, we're saying the probability someone plays AFL given that they play basketball. So we know that they're a basketball player. We know that they're in this circle. So there are 11 people to choose from. And of those 11 people, 8 of them play AFL. Let's look at probability of B given A. Probability they play basketball given that they play AFL. Well, it's similar to the last example. We know we're in the A circle. We know they play AFL. There are 16 choices. Of those 16 choices, 8 of them play basketball. Now, when you're giving an answer as a fraction, make sure it's simplified. It really doesn't matter if you give your answer as a decimal or a fraction. Just remember, if you're ever asked for probability of something, the answer always needs to be between and including 0 and 1. So decimal or fraction's fine. So this question here, if you've forgotten, this symbol means not. This means probability of not B given, not A. So we're saying we know the person doesn't play AFL. What's the probability they also don't play basketball? Well, if we look at our Venn diagram, there are 3 plus 10. There are 13 people who don't play AFL, and of these 13 people who don't play AFL, these 10 also don't play basketball. So the required probability is 10 over 13. So if you've forgotten, this symbol here means or union. So this says A or B. We know that we're in A or B. Now, A or B is the whole circle. It's these 19 people, everything inside the circles. So there are 19 people who play either AFL or basketball or both. We're saying what's the probability that we're in A given that we're in these circles. So there are 16 in the A circle out of the 19 inside at least one of the circles. Similarly, this symbol here means and. It just refers to this 8 in the middle. This is A and B. People who play basketball and AFL. So, given A means we know we're in the A circle. So there are 16 choices, and of those 16 choices, 8 of them are in the middle, are in A and B. It's 8 over 16, which is and a half. So hopefully you see that these two questions are actually asking the exact same thing, but I just wanted to make sure we went through what this symbol means. All right, let's look at a question involving conditional probability in which we use the formula. So the formula for conditional probability of A given B is the probability of both over the probability of the second one. Whichever event is listed second here goes on the bottom. So hopefully you saw we were essentially using this on a previous slide. When we calculated probability of A given B, we found the number in the middle, so the probability of both, and divided it by the number in the second circle. So two events A and B are said to be independent if and only if this is true. This says probability of A given B equals probability of A. So what exactly does that mean? Well, when we say probability of A given B, we know that B happened. We're saying what's the probability A also happens? So if B happening doesn't change the probability of A, the events are independent. That's what independent events are. They don't affect each other's chances. So let's go ahead and decide whether or not these two events are independent when I pick a card from a normal deck of 52. So let's let the event that I pick a red card be R and not spades. I'll just write as S not. Let's go ahead and calculate the probability that I pick a red card given that it's not spades. So using our formula at the top, this would be the probability that both happen. So the card I pick is both red and not spade, over the probability of the second one. This is what I meant before. Whichever one's written second goes on the bottom. So what's the probability that I pick a card that's both red and not a spade? Well, if it's red, it's not going to be a spade. The probability I pick a red card is just a half. What's the probability I don't pick a spades? Well, again, there are 4 suits: hearts, diamonds, spades, clubs. So if you don't get a spade, there are 3 out of 4 choices. You can still get 3 of the 4 suits. So a half divided by 3/4 is 2/3. The probability you pick a red card, given that it's not spades, is 2/3. That makes sense. If it's not a spade, it could be a heart, diamond, or club. 2 out of those 3 options are red cards. So what then is the probability of just picking a red? Well, we know that in the deck, half are red and half are black. So probability of red is a half. Probability of red given not spades is 2/3. Because these two things are not equal, we conclude that they are not independent, which means they're dependent. If events are dependent, it means they affect each other's chances, and of course they do. If you know that the card's not spades, that increases the chance that it will be red. So these two are dependent, meaning they're not independent. All right, let's now look at a harder question. So out of all Year 10 students, 15% scored an A in maths. Of these, 80% do at least 2 hours of homework, whereas over the whole grade, only 20% do 2 hours of homework. If a student who doesn't do at least 2 hours of homework is picked at random, calculate the probability they did not score an A in maths. So this is a pretty difficult question with lots of words, but notice that there are 2 sets here. We're talking about the set of students who scored an A and those who do 2 hours of homework. So I said previously, when you have 2 sets, it's really useful to draw a Venn diagram or two-way table. I drew a Venn diagram last time. I'm going to draw a two-way table this time. So a two-way table always has 4 rows and 4 columns. So there's 2 ways you can be in this question. You can either score an A in maths or not an A in maths. Now, two-way tables, unlike Venn diagrams, they have a column and a row for the total. So the other way you can either do 2 hours of homework, so I'll let that be H. This H means they do at least 2 hours of homework, or you cannot do 2 hours of homework. So now let's go ahead and fill out these cells. So we're told 15% scored an A in maths. So I'm going to put 15% here in the total. So if 15% scored an A in maths, that means 85% didn't, because percentages need to add to 100%, just like probabilities add to 1. So the question also told us that 20% of the total here do at least 2 hours of homework. So I'm going to put 20% there. That, of course, means 80% don't do at least 2 hours of homework. Okay, this is not enough. We need one of these numbers now to be able to fill in the rest of the table. So we get that from this information. Of these, so that's referring to the 15% who get an A in maths, of these people, 80% do at least 2 hours of homework. So 80% of 15% is equal to 0.8 times 15 is 12. So 12% goes here. So I need to put 3% here because this column here has to add to 15%. Of course, I need to put 8% there, so it adds to 20. And then we have 77% here. Okay, so we should have everything add to 100%. If you add these up, we do in fact get 100%. So the question asked us to find the probability that if I select someone who doesn't do at least 2 hours of homework, they did not score an A in maths. So what I'm saying is I know that they didn't do 2 hours of homework. What's the probability they also didn't score an A? So in other words, I want the probability that they didn't score an A given that they didn't do at least 2 hours of homework. So the formula for conditional probability tells us that on top we put the probability of both. So these are the people who both didn't score an A because they're in this column and didn't do 2 hours of homework because they're in that row. So that's 77%. And on the bottom, we just put the second one, which is H dash, 80% in total didn't do the homework. So the answer is just 77 over 80, and we're done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.